So this is capacitance. You can also call it as capacitor. Capacitance. So I'm going to talk about the fundamental concept of capacitance. So actually, capacitors are elementary electrical units. These are electrical units widely used in electrical and electronic engineering. A typical capacitor has two conductive plates. Between the plates, there is one called another plate, and this is dielectric. And the symbol of capacitance is this equal line here, and this should be equal. So you have two lines, connecting lines. And let's to describe this. So when this get connected to X terminal, it gets charged. And when this switch to this terminal, it get discharged. You'll study it further, don't worry. And another things you need to know is this. So you are asked, like in examination, you'll be asked to define capacitance. So you can say it as the ratio of charge stored on one plate to the potential difference across the plate, and this formula is important. And the unit of capacitance is farad, and 1 farad is 1 coulomb per volt. And this unit are also important, this pico, nano, micro, nano, pico. And the net charge of capacitance is 0. How this is 0? Because here are 2 and here is one positive, negative. So when this is being added, it gets 0. So capacitance does not store charge, it stores energy. And capacitance depends on geometry of the device and permittivity of the dielectric. Here is the formula. E epsilon naught A and D is the diameter, A is the area. So A is the area, D is the distance. So distance between the plates and geometric quantities. Okay, so whatever. So self-capacitance. There are two closely related notations of capacitance: mutual capacitance and self-capacitance. The unit is named as the Michael, so you don't have to learn this. I'll explain you later. And I already talked to you that formula for capacitance is charge upon voltage. So another thing also, self-capacitance of charged metal sphere. So this is very important. Metal sphere is not in, like, you're not find in Classme book, other books, but it is important. So metal sphere, the formula for metal sphere, so voltage gives Q over 4 pi this, and this is very important, metal sphere. So self-capacitance C sphere equals to QB, so Q volume 1 B. So this is the answer formula. So C sphere, capacitance of sphere is 4 pi epsilon naught R. And the conducting sphere of radius 1 meter is situated in a free space. Find its capacitance in order to raise its voltage. This capacitance of this capacitors by formula, this formula. And here you can see farad being impractically huge unit. So charge on sphere QB, so capacitance we already get it, and the capacitance times this are the charge, and this is coulomb. Do not get confused. Sometimes student gets confused writing C as a capacitance, but it is coulomb actually. It's the charge. Do not get confused. So analogy with idle gases. An interesting analogy can be made between capacitors and idle gases. So idle gases, you already studied about idle gas. So amount of substance. So you can write like PB equals to nRT. So N equals to B upon RT. So volume, continuous space pumping. So C takes, you don't have to. So other things. Okay. what to discuss? Energy. Oh, so this is actually important. So energy store in capacitors. So actually the area under the BQ is energy store. So this is energy store. So the formula for energy store is W. So W equals to 1 by 2 QB. So base into height. So this is height and this is base. You can area under the graph. Simple. Area under the graph. Okay. And by substituting some value, you'll get this. You can write it by yourself. And so here also, when the potential across or capacitors of one, if F is increased from this, so W equals to WF minus WI. So you can use this two concept, this one. Okay, so pause the video and look it once. So these are questions. Try to solve these questions 7.1, 7.2 and 7.3. Now other things you need to know, this is parallel plate, and so I have already discussed it on in my videos. You can get this. So I have discussed there about parallel and series capacitors. I won't be discussing this. So these are the same thing that here is. So this is actually the series capacitors. Okay, series capacitors. So you can pause the video and see the answers, and like this. So capacitors networks is very simple. Just pause it once and see the answer. Very simple. Okay. So these are the main thing that you need to know. And so discharging and charging capacitors, this is very important. Okay, so if you don't get any concept about this, then may have problem. Okay, so let's discuss in this section. Investigate. Okay, so initial state, no charge in capacitors, I told you already. And so like this, so only things you need to know is like for charging capacitors, let me write this one. So for charging capacitors, you'll just do like BC equals to 1 by E TRC. It's a very simple thing. Okay, so important is this. So yellow mark, this is very important. And other things are, so P of capacitors eventually tends to battery EMF. Okay, so BC no charge flow. Okay, and other things, and this. So from that formula you'll get this. So BC gives P, but this pen is not working. What happened? Alright, so let me tell you one thing about this. Like, okay, alright, so from that formula you'll get this. Okay, so PC gives P, so P naught E minus T RC. Alright. And discharging current also. Okay, so when you see this kind of curve, it is charging, and when you see this kind of curve downward, this is discharging. Okay, I'm just revising this. So time constant, like this tau, This tau is time constant, and which determines charging discharging of capacitors, and this is more charge to be. So I want to tell you one thing, that this discharging and charging capacitance, like really this question be asked in A2 physics, but this is not important. But you have to know the concept of this charging and discharging, but it won't asked in examination. So you can just to revise this notes, I'll add it uh, into um, the description section. You'll get this PDF also, and you can just do revise.